Pleasant day, learners. Before we proceed to our lesson, please bring with you a notebook and pen or pencil. Our topic for today is all about solving problems involving variations. Last meeting, we illustrate the four classification of variations: direct, inverse, join, and combine. So with on how to translate variation into statements. This time is how to solve problems involving variation. In solving problems involving variations, here are the steps. First, write the correct equation. When dealing with word problems, you should consider using variables other than x and y. You should use variables that are applicable to the problem being solved. Also read the problem carefully to determine if there are any changes in the direct variation equation, such as squares, cubes, or square roots. Step 2. Use the information given in the problem to find the value of k, called the constant of variation or the constant or of proportionality. Step 3. Rewrite the equation from step 1, substituting in the value of k found in step 2. And step 4, use the equation found in step 3 and the remaining information given in the problem to answer the question asked. Remember to include units in your final answer. Okay, so let us apply these steps for example number 1. If y varies directly as x and y is equal to 35 when x is equal to 7, find y when x is equal to 10. Analyze while reading the problem to identify the given. Make a representation for what is asked in the problem. Determine what equation to be used among the four kinds of problem of variation. Given. Okay, so for given, we have y sub 1 is equal to 35, x sub 1 is equal to 7, and x sub 2 is equal to 10. Use subscript to identify the given. What is asked? The value of y. For the representation, we have let y is equal to y sub 2. And for the equation, y varies directly as x, so y is equal to kx. Let's do the solution. Solve for k using y is equal to kx by substitution. Okay, so for step 1, y sub 1 is equal to kx sub 1. Use the information given in the problem to find the value of k, called the constant of variation or the constant of proportionality, and that is for the step 2. So k is equal to y sub 1 over x sub 1. And substitute the value of y sub 1 and x sub 1. We have now k is equal to 35 over 7, and that is equal to 5. 5 is our k or the constant of variation. Let us apply step 3. Solve for y sub 2, and that is for step 3. Y sub 2 is equal to a k x sub 2. Okay, so for step 4, use the equation found in step 3, which is y sub 2 is equal to kx sub 2 in the remaining information given in the problem to answer the question asked. So we have now y sub 2, substitute the value of k, which is 5, then multiplied by the value of x sub 2, which is 10. So y sub 2 now is equal to 50. Thus, y is equal to 50 when x is equal to 10. Example number 2. A car is traveling a distance of 150 kilometers. How long will it take the car to its destination if it travels at a speed of 30 kilometers per hour, 50 kilometers per hour, 60 kilometers per hour, and 80 kilometers per hour. Okay, so let us identify the given now. So given, the constant distance is equal to 150 kilometers, and for the rate or speed, first speed is 25 kilometers per hour. The second speed is 30 kilometers per hour. The third speed is 50 kilometers per hour, and the fourth speed or rate is 60 kilometers per hour. So we are going, what is asked in the problem? So we are going to identify that the unknown. So for the problem, the number of hours or time it will take the car to travel at the given rates or speed. Okay, so for the representation, let t is equal be the time. What do you think the equation of this problem? Or what kind of variation is this? Okay, so equation, we all know that distance is equivalent to rate times time, or d is equal to rt. So therefore, if we are looking for the time, t or time is equal to distance over rate. Okay, so for the solution, since t is equal to d over r, we can have the following values. So t is equal to distance over rate, or time is equal to distance over rate. For the first rate, which is 25 kilometers per hour, so 150 kilometers over 25 kilometers per hour, so that is 150 divided 25, that is 6, and that is, the time is 6 hours. And for the second speed or rate, we have 150 time is equivalent to 150 kilometers over 30 kilometers per hour, and that is equal to 5 hours. Okay, so for the third one, we have 150 kilometers over 50 kilometers per hour, so the time is equal to 3 hours. And for the fourth, we have now 150 kilometers over 60 kilometers per hour, and the time is equal to 2.5 hours. So let's do the table. Okay, for the rate, we have the 25, 30, 50, and 60. And for the time, for 25 rate or speed, we have 6 hours. For the 30 is 5 hours. And for 50, we have 3 hours. And for 60, we have 2.5 hours. Okay, so that is for problem number 2. For example number 3, the volume of a right cylinder varies jointly with the square of its radius and its height. When the radius is 2 cm and the height is 6 cm, the volume is 75.36 cubic centimeters. So what is the volume if R is equal to 3 centimeters and the H is 5 centimeters? Okay, so let us identify the given. So for the given, we have R sub 1 is equal to 2 centimeters, H sub 1 is equal to 6 centimeters, and for the B sub 1 or the volume, first volume is equal to 75.36 cubic centimeters. R sub 2 is equal to 3 centimeters and H sub 2 is equal to 5 centimeters. What is asked in the problem? So, the volume of a right cylinder when R is equal to 3 centimeters and H is equal to 5 centimeters. Let's do the representation. Volume, second volume is equal to, or that is B sub 2 is the volume when R is equal to 3 centimeters and H is equal to 5 centimeters. So for the equation, we have volume is equivalent to K R sub 2 and H. For the solution, solve for K by substitution. So we have now V sub 1 is equivalent to K R sub 1 raised to the second power H sub 1. So, let us substitute the value of volume, which is 75.36, and is equal to K. Substitute the value of R, which is 2 raised to the second power, and our first H is equivalent to 6. So, multiply 2 square by 6, and that is equivalent to 24. So, 75.36 is equal to K24 or 24K. So, the value of K now is equal to 3.14. So, that is the constant of variation. Okay, for the next one we have now, we're going to identify the value of the volume, the second volume. If the R is equal to 3 centimeters and H is equal to 5 centimeters. So, let us substitute the given value. So, for the second volume, we have equivalent to the constant, which is 3.14 multiplied by the value of R, which is 3 square, and multiplied by the value of H, which is 5. So, V sub 2 now is equivalent to 3.14 multiplied by 3 square is 9, multiplied by 5, and that is equal to 141.3 cubic centimeters. So, thus, the volume of a right cylinder B is equivalent to 141.3 cubic centimeters if the radius is equal to 3 centimeters and the height is equal to 5 centimeters. So, let us solve for the example number 4. Y varies directly as X and inversely as Z, and Y is equal to 6 when X is equal to 8 and Z is equal to 4. We're going to find Y when X is equal to 12 and Z is equivalent to 9. So, for the given, we have Y sub 1 is equal to 6, X sub 1 is equal to 8, Z sub 1 is equal to 4, X sub 2 is equal to 12, and Z sub 2 is equal to 9. Okay, so what is asked? The value of Y. Then we are going to do the representation. So, let Y sub 2 is equal to Y when X is equal to 12 and Z is equal to 9. Okay, so what about in this problem? What equation are we going to use? So, it's a combination of direct and inverse variation. Okay, so for the equation, Y varies directly as X and inversely as Z. So, Y is equal to Kx over Z. Solution? Solve for K using Y is equal to Kx over Z by substitution. Okay, let us substitute the given value. So, Y is equivalent to Kx over Z, or Y sub 1 is equal to Kx sub 1 over Z sub 1. So, looking for the constant, we have now K is equal to Y sub 1, Z sub 1 over X sub 1. So, next, we have now substitute the given value. For K is equivalent to the given value of Y. Y sub 1 is 6. For Z sub 1 is 4. And for X sub 1 is 8. So, multiplying 6 times 4, that is equal to 24. So, K now is equal to 24 over 8. And K is equal to 3. Okay, so, we're going to find the value of Y sub 2. Substitute the given values. Y sub 2 is equal to Kx sub 2 over Z sub 2. Okay, then Y sub 2 now is equal to the constant, which is 3 multiplied by x sub 2, which is 12 over 9. Multiply 3 times 12, and that is 36. So y sub 2 is equal to 36 over 9, and that is equal to 4. So y sub 2 natin is equal to 4. Thus, y sub 2 is equal to 4 when x is equal to 12 and z is equal to 9. So, learners, I hope that you learn a little bit, or shall I say, you learn a lot. Thank you very much, and God bless us all.